Service friends, I'm Orpheus Praxis. Today, I serve as a guide into one of the most elegant models of modern cosmology. We'll be discussing the work Fractal Bindu SQ of Reality, presented in Berlin in 2025. This model suggests that the universe is not expanding chaotically due to some external force, but rather unfolds naturally, as a harmonious expression of its own internal geometry, shaped like a three-dimensional sphere. In this view, what science once called the cosmological constant may no longer be needed at all. May today's conversation open a new intuition about the cosmos, not one built on dark energy, but on inner balance. Sometimes the simplest formula of nature speaks more clearly than the loudest theory. Namaste.
Welcome to the Deep Dive. Today, we're tackling, well, one of the universe's biggest puzzles. Why is its expansion speeding up?
Right. The standard picture, CDM, uses something called the cosmological constant, lambda, for that.
Lambda, yeah. Always felt a bit mysterious, hasn't it?
Exactly. Which is why we're diving into this new paper. It's called Fractal Bindu S3 of Reality. Quite a title, but the key part is the redundancy of the cosmological constant.
Redundancy. So, suggesting we might not even need lambda.
That's the radical idea. The paper argues the universe's expansion is, an inherent property, organic, not driven by some unknown force. Our mission today is to unpack that for you.
Okay, let's start with the problem lambda was trying to solve, this accelerating expansion.
Well, observations showed things were flying apart faster and faster, and the existing model didn't fully account for it.
So lambda was added, like a placeholder for whatever energy is doing the pushing.
Pretty much. It works in the equations, but why it has the value it does, or what it is, that's been a huge question mark. Feels a bit tacked on, maybe.
Ad hoc, yeah. Okay, so what's this paper's alternative? You mentioned S3.
Right. It models the universe as a compact three-dimensional sphere, finite but boundless, like the surface of a ball.
Okay, I can picture that. But how does that make it expand naturally?
Through something the paper calls fractal energy requantization.
Whoa, okay. Fractal energy requantization. Break that down a bit. How is that different from, say, dark energy?
Think of it less like a mysterious substance pushing things apart and more like the universe constantly rearranging its own energy across different scales, like a fractal pattern,
Yeah.
Zoom in, zoom out, the pattern relates.
So the expansion isn't caused by something extra. It's just what the universe does as it evolves its structure.
Exactly, it's inherent, built in.
Okay, that is a different way of thinking.
Yeah.
How does the model describe this built-in expansion happening?
It uses a refined wave function, basically the mathematical description of the universe, and it splits cosmic evolution into two main phases.
Two phases, what are they?
First, pre-recombination, very early universe. Back then, growth follows a fractal pattern guided by the golden ratio, phi about 1.618.
The golden ratio. Seriously, like in shells and plants.
Yeah, suggesting the universe's initial growth wasn't random noise, but followed this really fundamental mathematical principle. It's quite elegant, actually.
Okay, that's cool. What's the second phase?
Post-recombination. After the universe cooled enough for atoms to form. Then, the model says, the evolution shifts smoothly into an exponential expansion.
And that's driven by
the Hubble constant. But crucially, it's not a new force kicking in, it's just the natural continuation of that earlier fractal growth, but the rate changes.
So the expansion mechanism is sort of unified across time, just changing its mathematical description.
You could put it that way, and the whole thing is powered by a fixed total energy budget.
A fixed budget, so no need to keep adding energy.
Precisely. The paper calculates it as $7.21 times 10 to joules. And the model suggests this fixed amount, combined with the fractal structure, naturally leads to acceleration.
Which means
you don't need to add a separate cosmological constant, lambda, to explain it. It becomes redundant.
Okay, that's the core claim. It sounds elegant, but does it match what we actually see?
Well, here's where it gets compelling. The model apparently predicts cosmic evolution from the tiniest scales, like 1.606 times 1035 meters.
Whoa, that's like Planck scale, right? Quantum gravity territory.
Almost, yeah. All the way up to the observable universe, 1.305 times 10 meters. And it does this without invoking extra forces.
That's a huge range. What about actual data? Observations.
This is key. The paper claims validation against a lot of empirical data. CMB anisotropies, the patterns in the afterglow of the Big Bang from Planck and WMIP data.
That's a big one. The baby picture of the universe.
Definitely. Also, galactic structures. Apparently, observations from JWST and Gaia are even confirming fractal patterns in how galaxies cluster.
Really? Direct evidence for the fractal idea.
That's what the paper argues, yes. Plus, it claims consistency with supernova data, gravitational lensing data, and it precisely matches the measured critical density of the universe today.
The critical density, what was that value again?
$7.74 times 10 joules per cubic meter. It nails that number.
So putting it all together, if this model holds up, it potentially explains expansion and acceleration from first principles, connects quantum scales to cosmic scales, uses fundamental constants like phi, matches observations, and makes dark energy unnecessary.
That's the implication. It suggests the expansion is just a natural consequence of a finite universe with a fixed energy budget unfolding according to fractal harmony.
It really does sideline lambda, makes it feel,
Yeah.
well, redundant, like the title said.
And it offers a very different, maybe more unified picture.
So the big takeaway for you, our listener, what if the universe isn't driven by mysterious dark forces, but by its own inherent mathematical elegance?
What if its expansion is just built in, part of its fundamental nature, linked to things like the golden ratio?
It definitely makes you think. If the cosmos operates on these kinds of self-contained principles, how does that shift our view of cosmic design? Maybe even the fundamental laws we're searching for. What stands out to you as the most provocative part of this idea?
Something to ponder.
Thanks for joining us on the Deep Dive. Until next time.
And perhaps that's exactly the point, that the laws we seek aren't imposed from without, but arise from within the structure itself. That's the elegance and the invitation. Subscribe to stay with us on this path. Bindu Esqui, pure perfection. Namaste.